In today's lesson, we'll be learning about the method of elimination. In our first example, we want to solve the linear system by elimination. First, we need to arrange the two equations so that like terms are aligned. Our first equation is 4x plus 3y is equal to 13. Meanwhile, our second equation is 5x minus 4y is equal to negative 7. Fortunately, like terms are already aligned. 4x and 5x are like terms, positive 3y and negative 4y are like terms, and positive 13 and negative 7 are also like terms. Finally, we need to choose the variable we wish to eliminate. I'm going to arbitrarily choose a variable of x. You can choose a variable of y if you want. Next, if necessary, multiply one or both equations by a value so that they have the same or opposite coefficient in front of the variable you wish to eliminate. Let's take a closer look at these two equations. 4x plus 3y is equal to 13, and 5x minus 4y is equal to negative 7. For the red line, the coefficient of x is positive 4, and for the blue line, the coefficient of x is positive 5. These are neither the same or opposite. Therefore, we need to manipulate these equations to get these numbers the same or opposite. I'm going to call this equation 1, and I'm going to call this equation 2. Take a close look at the numbers in front of x, 4 and 5. We need to find the lowest common multiple of 4 and 5. You can do that work on your own or in your head, and the lowest common multiple of 4 and 5 happens to be 20. Therefore, I need to manipulate these equations such that the number in front of x becomes 20 for both lines, which means I'm going to have to multiply the first line by 5, and I'm going to have to multiply the second line by 4. So everything in the first line gets multiplied by 5. 4x times 5 is 20x. Positive 3y times 5 is positive 15y. And 13 multiplied by 5 is 65. Now I'm going to multiply everything in the second line by 4. 4x times 4 is 20x. Negative 4y times 4 is negative 16y. And negative 7 multiplied by 4 is negative 28. As you can see, the coefficient of x is now the same. As mentioned beforehand, this equation was multiplied by 5, and this equation was multiplied by 4. That gave us 20x plus 15y, which is equal to 65, and 20x minus 16y, which is equal to negative 28. At this point, you can add or subtract as needed to eliminate one variable. Now, I'm going to choose to subtract these two equations. That is going to eliminate my variable of x. If you add, you will not eliminate the variable of x. So 20x subtract 20x cancels out. Positive 15y subtract negative 16y is positive 31y. And 65 subtract negative 28 is positive 93. As you can see, we've successfully eliminated the variable of x. And now we just need to solve for y. When we subtracted these two equations, we successfully eliminated the variable of x, and we were left with 31y is equal to 93. Remember, we want to isolate y, but y is stuck with a multiply by 31. To get rid of this, we need to do the opposite operation to both sides of the equation, which means I'm going to have to divide both sides by 31. So those 31s cancel out, which leaves me with just y, and 93 divided by 31 is just 3. Therefore, I've successfully solved for y, and y is equal to 3. Next, I want to substitute y is equal to 3 into either equation 1 or equation 2 and solve for x. So I'm going to substitute y is equal to 3 into equation 1. You can do this into equation 2 if you want. Doesn't really matter. Equation 1 is 4x plus 3y, which is equal to 13. The 4x stays the same. Instead of writing y, I'm going to write 3 in brackets. Simplify some of these numbers. The 4x stays the same. 3 times 3 is 9. Remember that we want to isolate x, but x is stuck with a multiply by 4 and a plus 9. So we need to get rid of these. I'm going to get rid of the plus 9 by subtracting 9 from both sides of the equation. So positive 9 subtract 9 cancels out, which leaves me with just 4x, and 13 subtract 9 is just 4. Again, we want to isolate x, but x is stuck with a multiply by 4, so we need to do the opposite to both sides of the equation. I'm going to divide both sides by 4. Those 4's cancel out. X is equal to 1. Therefore, I've just solved for x, and x is equal to 1. I'm going to write a concluding statement. Therefore, the solution, which is also a point of intersection, is 1, 3. We need to check and see if this solution is indeed the correct answer, which means we need to do a left side, right side check for both equation 1 and equation 2. Let's start with equation 1. So I'm going to sub 1, 3 into equation 1. Equation 1 is 4x plus 3y equals 13. Instead of writing x, I'm going to write 1 in brackets. Instead of writing y, I'm going to write 3 in brackets, and everything else stays the same. Let's simplify this. 4 times 1 is 4, 3 times 3 is 9, and 4 plus 9 is 13. So you can plainly see that the left side is indeed equal to the right side, which means this point lies on line number 1. I'm going to do the exact same thing for the second equation. So I'm going to say sub 1, 3 into equation 2. Equation 2 happens to be 5x minus 4y, which is equal to negative 7. So instead of writing x, I'm going to write 1 in brackets. Instead of writing y, I'm going to write 3 in brackets. And that's going to be equal to negative 7. So let's simplify some of these things. So 5 times 1 is 5. Negative 4 times 3 is negative 12. That's going to be equal to negative 7. 5 subtract 12 is negative 7. So you can pretty much see that the left side is equal to the right side, which means that this point does lie on line number 2. Let's end this problem with a concluding statement. So since left side was equal to right side for both equations 1 and 2, therefore, the solution is indeed 1, 3.